Hello, welcome to the video lecture on Quine Mccluskey's method of minimization. Simplification of Boolean expression is a practical tool to optimize digital circuits. Several techniques have been introduced to perform the minimization, which involves using Boolean postulates and theorems and using Karnaugh map. Minimization using Boolean algebra requires high algebraic manipulation skills and will become more complicated when the number of terms increases. Karnaugh map is a visualization technique which is easier to use than Boolean algebra but becomes more complicated when the number of variables increases. 6. Quine Mccluskey's algorithm, also known as method of prime implicants, was developed by Willard Quine in the year 1952 and extended by Edward Mccluskey in the year 1956. Quine Mccluskey method employs a systematic step-by-step procedure to find a simplified standard form of expression for the Boolean function. Although Quine Mccluskey algorithm is functionally identical to Karnaugh map, the tabular form makes it more efficient for use in computer algorithms. In this method can handle any number of variables. The basic idea behind Quine Mccluskey method is xy plus xy bar equal to x, where x can be a variable or a group of variables and y is a variable. It means that when two terms contain the same variables differ only in one variable, they can be combined together to form a new term which is smaller by one literal. For example, a b bar c d can be combined with a b bar c d bar since they vary only in one variable. They vary only in the last variable. They can be combined together to form a new term which has one literal less compared to the original term. The binary representation of this term is denoted here. This rule is repeatedly applied and whatever we get at last is a prime implicant. Let us consider a simple example to illustrate this. Consider a 4-variable function which has 4 minterms. There are some minterms which differ only in one variable. Consider the first 2 terms, they differ only in one variable. The first 3 variables are same, the last variable is only different. They differ only in the last variable. The same way, the last 2 terms can be combined together because they differ only in one variable, the last variable. The first 3 variables are just the same. A, B bar, C bar, here again it is A, B bar, C bar. Only they differ in the last variable. So these two can again be combined together. They can be combined to obtain this simplified expression. So when we combine these two terms together, we get a new term which is one literal less compared to the original term. So this variable d gets eliminated. We just get a bar, b bar, c bar. The same way combining these two terms, we get a, b bar, c bar. Again we can apply the same algorithm to these two terms because they again differ only by one variable. They differ only by the first variable. So they both can be combined together to get a new term which is one literal less compared to the original term. So this reduced term is called prime implicant. A prime implicant is a product term which cannot be further reduced by combining with any other product term of the given Boolean function. So this is the basic idea behind Quine Mccluskey's method. The following are the steps to be followed in Quine Mccluskey's method. First step, a set of prime implicants of the function must be obtained. In second step, from the set of all the prime implicants obtained in step 1, a set of essential prime implicants must be determined by preparing a prime implicants chart. In the third step, the minterms which are not covered by the essential prime implicants are taken into consideration and a minimum cover is obtained from the remaining prime implicants to obtain the minimal SOP term. So these are the basic steps which are involved to find the minimal SOP term for the given Boolean expression. First we have to find the prime implicants and from that we have to find the essential prime implicants by using prime implicant chart. and the leftover terms should be covered. A minimal cover has to be made from the leftover terms to find the final expression. So these are the steps which should be involved to find the minimal SOP term. So let us consider let us deal with each and every separate step in detail. So the procedure for finding the prime implicants is given below. So the first step, each minterm should be expressed by its binary representation. The binary equivalent of the minterm should be represented in the first step. Next, the minterm should be arranged according to the increasing index. Index can be defined as the number of ones in the minterms. So the minterm should be arranged according to the number of ones present in the minterms. And groups should be formed so that groups can be formed by combining minterms having same number of ones. So groups should be obtained in second step. And each term in the group should be compared with the successive group. So each term should be compared with the successive group. So each term should be compared with all the members of the successive group, and from which matched pair should be formed. So in third step, matched pair should be formed when they differ only in 1 bit position. So the same process is repeated for all group of terms. So thus one stage of elimination is completed. The next stage of elimination can be obtained by using the new terms. According to this stage, two terms can be combined only when they differ only by 1 bit position. The cycle has to be continued until no new term can be found, no further elimination is obtained. So all the terms which remain unchecked during this process are to be considered as prime implicants. So these are the steps which are to be involved in finding the prime implicants. And then from the prime implicants, essential prime implicants have to be found out by using prime implicants chart. So in the prime implicants chart, prime implicants are represented in rows and the minterms are represented in columns. A cross mark should be placed in each row to show the composition of the minterms that make the prime implicants. A complete prime implicants table should be inspected for a single cross. So whichever prime implicant is going to have a single cross, that is called the essential prime implicant. So the remaining minterms are to be covered. Minimum cover should be made with the remaining minterms to find the minimal SOP term. So these are the steps which should be involved to get the minimal SOP term. Thank you for watching this video.